In this video, we are going to talk about probability. We're going to go over how to describe probabilities using numbers and words, and we're going to talk about theoretical probability versus experimental probabilities. All right, let's start with defining probability in mathematics. Mathematically speaking, probability is determining the likelihood that an event will occur. We measure probability using values between 0 and 1. 0 represents the probability that the event is impossible. It cannot occur. And so thinking about the words that we use for that, we would use impossible. There is a 0% chance that that event will occur. But we could also write this as a fraction. Our fraction is determined based on the total possible outcomes that could happen, being our denominator, and the numerator is represented by the possibility of getting a certain outcome. So, for example, if I am talking about rolling a 6-sided dice, my total possible outcomes in doing this would be 6. So my denominator is out of 6 possible outcomes. The outcomes that I could get would be 1, 2, 3, 4, 5, or 6. In this 6-sided dice, it is impossible for me to roll a 7. I have 0 opportunities on that 6-sided dice to roll the number 7. There's a 0% chance of that happening. It is impossible. These are all of the ways that we would describe the probability of me rolling a 7 on a 6-sided dice. On the other hand, if I am looking at 1, this means that it is certain that that event will take place. It has to happen. There is a 100% chance that that event is going to occur. So in my dice example, it is 100% chance that I will roll a 1, 2, 3, 4, 5, or 6. It is certain that that will happen. There are 6 chances out of 6 for me to roll a 1, 2, 3, 4, 5, or 6. And we can use any of the numbers between 0 and 1 to continue calculating probabilities. Here in the middle, we have an equally likely chance for something to happen if it's right in the middle between 0 and 1. This is going to be represented by 50% chance of the event occurring. And if I am using my dice example again, I have a 50% chance of rolling an even number on that 6-sided dice because there are 3 opportunities for me to roll an even number out of a total of 6 outcomes. Looking at the values between 0 and 0.5, we would call any opportunity that lands in between here as unlikely. So for example, if I have my 6-sided dice and I want to know the likelihood that I would roll a 2 on that 6-sided dice, there is 1 opportunity out of 6 that I would roll a 2 on that 6-sided dice. Therefore, it is unlikely that that will happen because there's less than 50% chance. Okay, I think that percentage comes out to 16.67%. Now looking at the values between 0.5 and 1, if we land in between these values, we would describe that as a likely event. If it's more than 50% but less than 100%, we can use the term likely. Going back to my 6-sided dice, if I want to know the likelihood that I would roll a 1, 2, 3, or 4, there would be 4 opportunities out of 6 for me to roll the numbers 1, 2, 3, or 4. So that is more than 50%. It would be 4 out of 6. It would be likely for me to roll a 4 out of 6. And I believe the percentage for that would be around 66.67%. Again, more than 50%, but less than 100%. When children learn to think about probability, they begin thinking about these words that we use, such as impossible, unlikely, equally likely, likely, and certain. These are the ways that we describe these probabilities prior to needing to or being able to use numbers, fractions, percentages. Once children learn about fractions and percentages, then they start adding that to their concept of probability, attaching the words to the numbers. All right, let's move on to talking about theoretical probability versus experimental probabilities. Theoretical probability is what should happen when you flip a coin or when you roll the dice, right? We determine this mathematically, okay? We can calculate the probability of what should happen when you roll the dice before it ever takes place. On the other hand, we have experimental probability, okay? Experimental probability is what actually did take place, okay? We can only determine this by doing the actual experiments, right? By actually rolling the dice, okay? You have a 1 out of 6 chance of rolling a 2 when you roll the dice. That's the theoretical probability. But when you actually roll the dice, you might not get a 2. In fact, it is unlikely that you would. But even if you roll that dice 6 times, that does not mean one of those times has to be a 2. That is just the theoretical probability, how we can determine that mathematically. It might be that you roll a 2 every single time that you roll the dice. It might be that you never roll a 2 when you roll the dice. That would be the experimental probability, what actually takes place. All right, thank you for watching. If you have any questions, please let me know.